we have learned how to prepare hydrogen chloride gas. Then how is hydrogen chloride gas prepared? By mixing sodium chloride with concentrated sulfuric acid. We prepared hydrogen chloride gas, and the temperature kept was less than 200 degrees Celsius. And why the temperature is kept less than 200 degrees Celsius is already been told. We know that. Then purification, collection and identification of the gas is also done. Then we have done one experiment to demonstrate that hydrogen chloride gas is heavier than air. Then another thing is that we also did an experiment to show that hydrogen chloride gas is highly soluble in water. Now today we'll be learning how to prepare hydrochloric acid in laboratory using hydrogen chloride gas. That we'll learn today. So laboratory method of preparation of hydrochloric acid. Now the aqueous solution of hydrogen chloride gas is known as hydrochloric acid. So what is hydrochloric acid? It is aqueous solution. Aqueous solution means when you pass hydrogen chloride gas in water, then you will get aqueous solution of hydrogen chloride gas, which is also called hydrochloric acid. So what is hydrochloric acid? In short, it is aqueous solution of hydrogen chloride gas. So how it is prepared? It is prepared by dissolving hydrogen chloride gas in water. So how it is prepared? It is prepared by dissolving hydrogen chloride gas in water. So it is very simple. Hydrogen chloride gas has to be dissolved in water to get hydrochloric acid. The gas is passed into water until no more gas is absorbed. That means you need to pass the gas until and unless no more gas is absorbed. Then the product is concentrated and contains about 36% of hydrogen chloride by mass. Then that means you have to make saturated solution of hydrogen chloride gas in water, so that no more of hydrogen chloride gas can be added. So up to that point, up to that limit, you need to pass hydrogen chloride gas in water. Then you will get a concentrated acid which contains 36% of hydrogen chloride by mass. That means if you take 100 liter of hydrochloric acid, then in that 36 liter will be hydrogen chloride and rest will be water. So let's see, this is the procedure how we prepare hydrochloric acid from hydrogen chloride gas. So let's see, an inverted funnel. You can see here, this is an inverted funnel. Here is an inverted funnel connected to the hydrogen chloride gas supply. So this inverted funnel is connected to the supply of hydrogen chloride gas. This is hydrogen chloride gas coming through this pipe, and this inverted funnel is connected to the supply, connected to the hydrogen chloride gas supply. It is placed in the beaker in such a way that it just touches the water taken in the draw. Now how we need to keep this inverted funnel? It is kept in such a way that it simply touches the water. It should not immerse inside the water, but it should simply touch the water. So this funnel should touch the water. Since HCl gas is highly soluble in water, the water rises up in the funnel. Since hydrogen chloride gas is highly soluble in water, the water rises up in the funnel. Back suction occurs and in turn the level outside the funnel falls, creating an air gap between the rim of the funnel and the surface of water. So what happened is, since this hydrogen chloride gas is highly soluble in water, so what happen is this water level may rise. Water level may rise. Why water level will rise? Just we have done in fountain experiment that this is the supply of hydrogen chloride gas, and since this has the space, this space is occupied by hydrogen chloride gas, and once this hydrogen chloride gas is in contact with water, whole of the hydrogen chloride gas gets dissolved in water. As a result, there will be low pressure zone. Here low pressure zone will be created and this water level may go up. Water level may go up. Back suction occurs. Back suction, that means the water may get into this. Okay, water, instead of supplying hydrogen chloride gas to water, water may rise up and go. So that is called back suction. So what is back suction? Back suction means actually hydrogen chloride gas has to come and mix to the water, but because of the creation of low pressure here, this water may rise up and go. So that is back suction. So back suction occurs and in turn the level outside the funnel falls, creating an air gap between the rim of the funnel and the surface of water. So air gap will be there. Okay, the pressure outside and inside then becomes equal. So as a result what will happen is, the pressure inside and outside will become equal, and the water which had risen in the funnel falls down again, and the water which has risen up falls down. This process continues till the water in the trough is saturated with the hydrogen chloride gas, resulting in the formation of hydrochloric acid. So what is done? Whenever hydrogen chloride gas is supplied, this funnel has to be lifted little up. Okay, when hydrogen chloride gas, first of all, let the hydrogen chloride gas come in contact with this water, and as soon as hydrogen chloride gas comes in contact with this water, this funnel is to be arranged in such a way that it just goes up. Like this, creating air gap, so that this water may not rise up, and so that there may not be back suction. So in order to prevent back suction, there is the funnel arrangement is to be done. And these two process, first of all, whenever hydrogen chloride gas comes, this is to be done, and once hydrogen chloride gas mixes, then it is to be lifted up. As a result, there is air gap, so that the water may not rise up in this funnel. So this is to be done until and unless saturated solution of hydrogen chloride gas and water is made. So this is back suction. Then let's see mechanism by which back suction is avoided or minimized. So how can we avoid or minimize back suction? The funnel arrangement: A. Prevents or minimizes back suction of water. B. Provides a large surface area for absorption of hydrogen chloride gas. So why we are using funnel? Because funnel, number one, prevents or minimizes back suction of water, number one. Number two, it provides a large surface area for absorption of hydrogen chloride gas. So let's see, why is funnel arrangement used? Hydrogen chloride gas is sufficiently soluble, so it is absorbed in water more quickly than it is being generated in the flask. So how fast it is generated in the flask? Even faster than that, it dissolves in water. In this case, the pressure in the delivery tube and flask is reduced, and the atmospheric pressure from outside forces the water back up to the delivery tube. This effect is called back suction. So what happens is, Now this delivery tube and the delivery tube will be in low pressure zone. Okay, then water always flows from higher pressure to lower pressure, so water may go up in the delivery tube and from delivery tube to the flask. So so this is called back suction. So back suction, in simple word, if you have to say, back suction is, instead of supplying hydrogen chloride gas to water, water may rise up in the delivery tube or the funnel. That is called back suction. If the tube is made of ordinary narrow glass tubing, the water will quickly fill it and pass over into the generating flask. This would stop the reaction and might result in an explosion due to the heat produced when water comes in contact with the hot concentrated sulfuric acid. Actually this is connected to this is directly connected to the lab preparation of hydrogen chloride gas. So the delivery tube, if you can remember, the delivery tube from which hydrogen chloride gas was coming, that delivery tube is this, and this is connected to the funnel. So if water level goes up from this delivery tube, it may enter into concentrated sulfuric acid. As a result, there may be explosion. So this back suction has to be avoided. So in order to avoid this back suction, this funnel is used. So funnel arrangement, I think you understood why funnel arrangement is done. If the tube is made of, if the delivery tube is made up of very ordinary and narrow glass, it may explode, it may break, and it may result in an explosion due to the heat produced when water comes in contact with hot concentrated sulfuric acid. So for this reason, funnel arrangement is done. Then what are the precautions need to be followed while making hydrochloric acid? To prevent such an accident, an empty flask antisuction device is put between the generative flask and the water trough. So in order to avoid such an accident, what is done? Antisuction device is used. What is used? Antisuction device is used. And it is kept in between the generative flask from where hydrogen chloride gas is generated, coming. Between that and between water trough, there is antisuction device. If the water goes up, then that water will be collected into that empty flask, so that the water will not go to the generative flask, and so that there will be no explosion. So what is done? The funnel arrangement, inverted funnel arrangement can minimize back suction, but back suction may occur. So if back suction occurs, then there will be explosion. So in order to reduce this explosion, in order to prevent this accident, anti-suction device, empty flask is used, which is acting as anti-suction device. If the water is rising up into the funnel, then that water is collected into this empty flask. As a result, there will be no explosion. In case the back suction occurs, the water will collect in it and will not reach the generating flask. So a dilute aqueous solution of hydrochloric acid gets gradually concentrated on distillation till the concentration of the acid reaches 22.2% HCl by weight and 77.8% water by weight, which boils at 110 degrees Celsius. No further increase in concentration is possible on boiling, as molecules of HCl get mixed with water vapors. So how is concentration of hydrogen chloride is increased? Hydrochloric acid is increased in water by distillation, and this percentage of HCl cannot be increased more than 22.2%, which boils at 110 degrees Celsius. No further increase in concentration can be done, as molecules of hydrogen chloride get mixed with water vapor. So if you go on increasing, if you go on distilling, then if you really want to get a more highly concentrated HCl, then it cannot be done, because on boiling water vapor is produced, and with water vapor even HCl molecule will also get mixed up. So this can be boiled up to the temperature of 110 degrees Celsius only, not more than that. If you boil more than 110 degrees Celsius, then HCl molecules may mix with water vapor. So a constant boiling mixture or azeotrope. So what is azeotrope? A constant boiling mixture. What is azeotrope? A constant boiling mixture is called azeotrope, is a solution which boils without any change in its composition. So azeotrope or a constant boiling mixture is a solution which boils without any change in its composition. That means it need to boil without changing its composition. If you boil more than 110 degrees Celsius, then the composition may change. So it should not be boiled above 110 degrees Celsius. So HCl acid forms constant boiling mixture at 110 degree Celsius. So you should not boil beyond 110 degree Celsius. Then what are the properties of hydrochloric acid? Physical properties: color, colorless; smell, pungent, choking smell. It has choking smell. Then taste, sour because it is acidic. Effect on skin: concentrated acid is corrosive and causes blisters on the skin. Solubility: readily soluble in water in all proportions. Boiling point 110 degrees Celsius. It is a volatile acid. Then chemical properties. Nature: aqueous solution is strongly acidic. There are three mineral acids which are very strong acids. They are hydrochloric acid, sulfuric acid, and nitric acid. And shows all properties of acids. Indicator: in moist litmus, if you dip blue moist litmus in HCl, then it will change to red. Methyl orange will change to pink, and phenolphthalein will be colorless. So it shows that it is an acid. Then how it reacts with metals. When hydrochloric acid reacts with metals, above hydrogen in the activity series, forming metallic chlorides and evolving hydrogen. So when metal reacts with any acid, it gives metal salt plus hydrogen. So here metal reacts with hydrochloric acid and gives metallic chloride plus hydrogen. Calcium reacts with, calcium is a metal, magnesium metal, zinc metal. When this metal reacts with hydrochloric acid, they give their chloride: calcium chloride, magnesium chloride, zinc chloride, and byproduct is hydrogen gas. So hydrogen gas along with the chlorides, metal chlorides, hydrogen gas is also prepared. Then action on oxides and hydroxides. How hydrochloric acid reacts with oxides and hydroxides or bases. You can say oxides, metal oxides and metal hydroxides are bases. So metallic oxide and metallic hydroxides reacts with hydrochloric acid to give salt plus water. You know that base plus acid gives salt plus water. Here base is metallic oxide and metal hydroxide, and acid here is hydrochloric acid. Since acid is hydrochloric acid, the salt will be chloride and water is produced. So if it is magnesium oxide, then reacts with HCl to give magnesium chloride plus water. If it is zinc oxide, then zinc chloride plus water. If it is iron oxide, then ferrous chloride plus water. If it is iron 2 oxide, then you get ferric chloride plus water, so on. So if sodium hydroxide, then NaCl plus water, so on. So when hydrochloric acid reacts with metal oxides or metal hydroxide, it gives metallic chloride plus water. This is important. If you know this, you can write the reactions. It is very tough to learn all this formula one by one, all these equations one by one. But if you know this, you can write any. Then with salts of weaker acids, it decomposes salts of weaker acids. Example: carbonates, hydrogen carbonates, sulfides and sulfides. So carbonates or hydrogen carbonates, when reacts with hydrochloric acid, one of the salt will be metal chloride with water and carbon dioxide gas. So whenever you are reacting carbonates or hydrogen carbonates with acid, it gives salt plus water plus carbon dioxide. So here also same thing, sodium carbonate reacts with hydrogen chloride, hydrochloric acid to give sodium chloride plus water plus carbon dioxide. So what you need to learn is metal carbonates or metal hydrogen carbonates, whenever reacts with any acid, it gives salt plus water plus carbon dioxide. Then with sulfides, metal sulfides or metal hydrogen sulfides, PHITE means SO3, plus hydrochloric acid, again the salts are same, metal chloride plus water, and since it is sulfite or hydrogen sulfide, so here instead of carbon dioxide it will be sulfur dioxide. So whenever you are using sulfite or hydrogen sulfide, the gas produced will be sulfur dioxide. Whenever you are using carbonates or hydrogen carbonates, the gas will be carbon dioxide, rest will be same. Then metallic sulfide or hydrochloric acid, when reacts, they give hydrogen sulfide as a gas, and the salt is same, metal chloride. So when hydrochloric acid reacts with ammonia, that means when hydrogen chloride gas combines with ammonia, it combines with ammonia to form dense white fumes of ammonium chloride. When ammonia gas is passed over hydrogen chloride gas, then we get a solid with white, a very dense white fume of ammonium chloride. So that is two gases combined to form solid. Two gases are combining to form solid. Then in precipitation reaction, let's see how it does the reaction. So dilute hydrochloric acid does not normally react with nitrates. So dilute hydrochloric acid does not normally react with nitrates. That means we need to take concentrated. However, lead nitrate and mercury 1 nitrate react with hydrochloric acid to give white precipitate of lead chloride and mercury 1 chloride. That means dilute hydrochloric acid does not normally react with nitrates, but dilute hydrochloric acid reacts with lead nitrate and mercury 1 nitrate to give white precipitate of lead chloride and mercury 1 chloride. You can see here lead nitrate reacts with dilute hydrochloric acid to give lead chloride precipitate, means solid insoluble substance, plus nitric acid is formed. And here also mercurous nitrate or mercury 1 nitrate, whatever you want to say, mercurous nitrate or mercury 1 nitrate, anything, plus hydrochloric acid, dilute hydrochloric acid gives mercurous chloride, which is insoluble solid, plus nitric acid. Precipitate of lead chloride dissolves on heating. So if you further heat this lead chloride, then it will not be insoluble, but it will be soluble. It dissolves in water on further heating. Then silver nitrate solution react with hydrochloric acid and it gives a thick curdy white precipitate of silver chloride. So whenever silver nitrate reacts with hydrochloric acid, it gives silver chloride insoluble solid white precipitate. This is white precipitate. White precipitate means white insoluble solid plus nitric acid. Then this AgCl, okay, the white precipitate is insoluble in nitric acid but soluble in ammonium hydroxide solution. So if you put this white precipitate, if you put this silver chloride in nitric acid, it is insoluble in this nitric acid. But if you put this substance in ammonium hydroxide solution, it dissolves, forming diamine silver chloride. So what it forms? Diamine silver chloride, which is complex salt, which is complex salt. So like this is complex salt. Why this is complex salt? Because complex salt, as I said you, it is inside the bracket and it will have a group of cations, okay, group of metal having one charge, positive ion, and one anion, cation and anion, okay. But cation, either cation will be group of atoms, or anion will be group of atoms represented within a bracket. That means it will have either 2 or 3 cations or 2 or 3 anions plus water. When dilute nitric acid is added to the clear solution of diamine silver chloride, a white precipitate of silver chloride is formed. That means this reaction can be reversed. If you put this diamine silver chloride again in nitric acid, then again this, if you put in nitric acid, then again you will get silver chloride, you will get back silver chloride. That means if you put this silver chloride in ammonium hydroxide solution, you will get diamine silver chloride, and if you put this diamine silver chloride again in nitric acid, you will get back silver chloride. So when exposed to light, silver chloride blackens since it decomposes into chlorine and metallic silver, which is liberated as a fine black powder. So again, if you expose this to light, then silver chloride blackens since it decomposes into chlorine and metallic silver, which is liberated as a fine black powder. So from this silver chloride, you can get silver back. That means you can get silver metal, and chlorine gas will be evolved. You will get a black substance, that is silver. So silver nitrate is used as a test for hydrochloric acid and also for chloride ion. That means this silver nitrate can be used for testing hydrochloric acid as well as for testing chloride ion. So this much for today, and with this we have finished chapter 8, that is hydrogen chloride. So let's do some recapitulation. So today we learned that how hydrochloric acid is formed. First of all, hydrogen chloride gas is prepared by mixing sodium chloride with concentrated sulfuric acid. Then whatever gas is formed, that gas is passed into washer bottle containing concentrated sulfuric acid in order to make hydrogen chloride gas dry. So then this dry hydrogen chloride gas is passed into water trough, into a trough having water, then how it is done? It is done by funnel arrangement. That means at one end of the delivery tube, one funnel is inverted, and this is kept just above touching the water level, and as the hydrogen chloride gas comes in contact with the water, this funnel is arranged in such a way that it moves up, keeping air gap. Otherwise there will be back suction, otherwise water may go up, creating back suction. So if back suction really takes place, then the water through this delivery tube may enter into the flask where hydrogen chloride gas is formed, which may cause explosion. So in order to avoid this explosion, in between water trough and this flask, one empty flask is kept, which is also said as anti-suction device, so that whenever by chance there is back suction of water, the water may get into empty flask, not into the flask where hydrogen chloride gas is formed. In this way, hydrochloric acid is formed by passing hydrogen chloride gas into water, and hydrogen chloride gas is highly soluble in water. So hydrochloric acid is formed, and in order to increase concentration of hydrochloric acid, you cannot boil the mixture. That is hydrogen chloride gas and water above 110 degrees Celsius. If you do so, then the hydrogen chloride molecules may go with water vapor. So it is to be kept at a constant temperature of 110 degrees Celsius. Then we'll get hydrochloric acid, and hydrochloric acid can turn blue litmus paper into red because it is acid. And this acid, hydrochloric acid, when reacts with metals, it gives metallic chloride plus hydrogen gas. When it reacts with bases, that is metallic oxides or hydroxides, then it gives metallic chloride plus water. When it reacts with carbonates or hydrogen carbonates, then it gives metal chloride plus water plus carbon dioxide. If it reacts with metal sulfides or metal hydrogen sulfides, then it gives metal chloride plus water plus sulfur dioxide. And when this hydrochloric acid reacts with metallic sulfide, then it gives metal chloride plus hydrogen sulfide. And generally dilute hydrochloric acid does not normally react with nitrates, but lead nitrate and mercury 1 nitrate reacts with dilute hydrochloric acid to produce precipitate, white precipitate. If it is lead nitrate, then lead chloride and nitric acid will be formed. And if there is mercury chloride, then mercury nitrate, then mercurous chloride and nitric acid is formed. Then if it is silver nitrate, then silver chloride and nitric acid is formed, and silver chloride will be in the form of precipitate, as you can see here. So silver chloride, the silver chloride precipitates with nitric acid because it is insoluble in nitric acid. But if you put this substance in ammonium hydroxide solution, then it will be soluble and forms a complex salt called diamine silver chloride. And if you put this diamine silver chloride back to nitric acid, you will get silver chloride again. And if you expose this silver chloride in sunlight, then it blackens and it decomposes into silver and chlorine. So this much for today. Thank you.